Hi everyone, this is another lesson on Math 082. We are in 4.3, sort of, or 4.4, and we are using the AC method for values of a greater than 1. And again, I mentioned in my previous video that this method is not really presented in the Math 082 textbook. So if you want to see it, you can look in the Math 083 textbook, which is still available online. So the AC method means that we need to find our A, our B, and our C. So if you want, you can pause this video and take a minute to do that, or you can keep watching and I'll pick those out for you. So our A is 8, our B is -2, and our C is -15. So our AC is 8 times -15, which is not going to fit in my box, but I think it gives us -120, and then B is -2. Ooh, all right. So as you can see, 120 is quite a large number, or -120. Okay, but we're looking for two numbers that, when subtracted or added, however you want to say, give us -2. So that means that, for example, I probably wouldn't want to pick -2 times 60 because they're very far apart. I want to find numbers that are very close together. So let's see, what else goes into 120? Well, we have -20 times 6. So we're getting closer together. What else do we have? We have 30. No, that's going backwards. Let's get a number that's smaller than -20. How about -10? How about -10 times 12? Okay, well those are 2 apart, so that looks promising. So let's try -10 times 12. That gives us -120. How about -10 plus 12? What does that give us? Well, that gives us +2. So when that happens, that just means that we need to switch our signs over here. So then I have +10 minus 12, and that gives me -2. So you can go back and erase those. So again, this is not going to work. This guy is going to work. So remember, in my previous videos, I mentioned when A is 1, we have this nice shortcut where we can write it like this, our factored form, okay? But in this case, A is not 1, A is 8. So we cannot use this shortcut method. We cannot do it. What we have to do instead is we have to do the longhand method, where we factor by grouping. So we are going to rewrite our middle term as the sum of +10x and -12x. Okay, and then we can use factoring by grouping. Now remember, when you use factoring by grouping, you have to artificially insert a plus sign here, and then just sort of scoot everything down. Okay, so that that negative sign can stay next to the 12. Remember, the signs belong to whatever number, whatever term they're next to. Okay, so let's keep going from here and factor out our GCF. If you need more practice or more help with factoring by grouping, please go back and watch those videos that I've already posted. Okay, so we've achieved our goal here. These are the same. So I'm going to pull out 4x plus 5. And then what's left over here is 2x minus 3. Okay, and remember, the beauty of these problems, just like many of the problems we do in this course, is that you can go back and use FOIL, or, in the case of other problems, some other method, to check your work. So let's do this. First, we have outer, then we have inner, and then we have, oopsies, I did that one twice, sorry. Then we have last. There we go, minus 15. Okay, and again, we have proven to ourselves that we ended up with the exact same thing that we started with. Those are the same. Okay, so that means that the final answer is what we had in factored form right here. All right, let's do one more example. So we have 3x squared plus 2x plus 7. So the first thing you have to do, always ask yourself, what is the GCF? In this case, I'm pretty sure the GCF is 1. Okay, but again, you always want to look at that, or else you're going to end up making more work for yourself. Okay, since the GCF is 1, then we ask ourselves, okay, well, how many terms does this guy have? Okay, and as soon as we count and we say that there's 3 terms, then we move on to use the AC method. Okay, so pause the video if you want to work ahead of me and see if you can do this problem on your own. Otherwise, you can watch me figure out A, B, and C and do the problem. All right, so we have A, B, and C. AC is 21, B is 2. Okay, well, let's think about what goes into 21. The only numbers that I can think of are 3 and 7. But 3 plus 7 is 10. Oops, I don't know why I wrote it that way. 3 plus 7 is 10. Right, if I had negative 3 times negative 7, well, that just gives me negative 10. We also have 21 and 1, but 21 plus 1 is 22. Right, or of course you could have negative 22. And I don't see any other factors. So sometimes this happens. Sometimes you exhaust the list of factors and you cannot find any two numbers whose product is 21 and whose sum is 2, or whatever your AC and your B are. So what do? Do we cry? Do we go home? Do we give up? What should we do with this problem? Well, just like we did in 4.1 when the GCF was 1, all we do is we just write prime. Okay? So that doesn't mean that there's not any way to factor this out. And later, we're going to use this magical thing called the quadratic formula. And if you don't get to the quadratic formula in Math OD2, you for sure get to it in Math OD3. And then we will learn how to find what are called irrational roots in our quadratics. But for right now, we don't need to trouble ourselves with all of that. Okay, all we have to do is, once we've exhausted all of our possibilities over here and realize that there isn't a integer solution that satisfies the requirement that AC is 21 and B is 2, then we can just write prime and then we're done.